Hi guys, welcome you all to my channel Explore Edu to Teach.
So the next topic that we are going to take in network analysis is the two-port network parameters. Already a video is uploaded on the two-port parameter basics where we have spoken about the driving point function as well as the transfer function. It is there in the I button also, so you can watch that video. That particular video talks about the basics. If you understand those basics, it will be easier for you to understand this concept over here. So I hope you are very clear with what I want to say. Do not forget to like, share, subscribe to my YouTube channel. There are many videos uploaded on network analysis on this particular chapter and on this particular subject. You can definitely go and watch it out in the YouTube channel of mine. Also at the same time, there will be many more videos which are going to be uploaded. So please subscribe to my YouTube channel, hit the bell icon so that you get notified if any new video goes live. Also share it to as many as you can so that everyone can get benefited out of these videos. Thank you so much. So let's dive into the topic today. Two-port network parameters is one of the most important topics, not only for your university exam but also from the point of view of different competitive exams. Such topics are always considered because many objective-based questions can be framed from this particular topic. We will be solving numericals on this topic, so that how you have to solve a particular problem if it comes in a university pattern wherein you have to solve all the steps, how you need to solve the same problem if it comes in a competitive exam wherein you have to solve a particular problem in lesser frame of time. So that is very important. So that's all going to be solved in this lecture, so do not skip the video, watch it till the end. All the concepts are going to be explained very well. So before going into the numericals, let's try to understand this two-port network. As I explained in the last class also, this is a two-port network which has V1 and I1. I1 is incoming current. It has V2, I2 is the incoming current. And the different parameters which are there is the Z parameter. Z parameter is known as the impedance parameter also and is open circuited. V1 is equal to Z11 into I1 plus Z12 into I2. V2 is equal to Z21 into I1 plus Z22 into I2. So Z11, Z12, Z21, Z22 are all these Z parameters. Similarly, the Y parameters are called as the admittance parameter or the short circuit. You have I1 is equal to Y11 into V1, Y12 into V2, and I2 is equal to Y21 into V1 plus Y22 into V2. Similarly, you have the H parameters, the hybrid parameters, in which you have V1 is equal to H11 into I1 plus H12 into V2. I2 is equal to H21 into I1 plus H22 into V2. Similarly, the inverse of this hybrid parameter is the G parameter, in which you have I1 and V2 and G11, G12, G21 and G22. So if you are very clear with this particular circuit in which you have the two-port network, what is V1, what is I1, what is V2, what is I2, you can be very clear with these parameters also. The next thing is the ABCD parameters and the inverse ABCD parameters. The ABCD parameters include V1, I1, V2, V2, I2, I2. Similarly, the inverse ABCD parameters include V2, I2, and you have A dash, B dash, C dash, and D dash. So you need to know these particular parameters very, very well. So you have to make a note of this particular equations. Please note it down. It is there. This notes also there in the description box of my this particular video. You can download it from there. You have to remember this particular equations very well. Once you've understood these equations very well, it will be easy for you to apply in the numerical. So we will be solving a numerical wherein we'll try to apply these particular equations over there and try to find out the different parameters. So before going on to a numerical, let us understand this condition of symmetry and reciprocity. So when you have a Z parameter, the symmetry condition, that is if it is satisfied, we have Z11 is equal to Z22, and if the reciprocity condition is satisfied, we have Z12 is equal to Z21. Similarly, if you have Y parameters, we have Y11 is equal to Y22 and Y12 is equal to minus Y21. The H parameter indicates mod of delta H is equal to 1 and H12 is equal to minus H21. And the ABCD parameter indicates A is equal to D and your AD minus BC is equal to 1. So this is the most important thing. This satisfies the condition of symmetry and reciprocity. I hope I'm very clear with this. So these are the equations of my z, y, h and g parameters and my ABCD and inverse ABCD parameter. Similarly, this is the condition for symmetry and reciprocity. I hope I'm very clear with this. Now let us try to apply the equations that we learned onto a numerical. So we will try to solve the problem in both the patterns, like in a university pattern, wherein you have to solve each and every step, as well as in a competitive exam like GATE, wherein time really matters and you have to be quick. So I'll show you certain shortcut techniques also. So please hold on to the video and listen to me very well. So if you look at this particular circuit, wherein we have V1, I1, we have a resistor combination over here, 10 ohms, 10 ohms, 10 ohms. We have V2 and I2. The question is to find out Z, Y, H and ABCD parameter. So for that, firstly, you have to be very clear with this Z parameter equation, Y parameter equation, H parameter equation and ABCD parameter equations. Now this circuit is given to you. You have to find out different values. So firstly, you have to apply KVL in all the meshes which are there over here. So you have mesh 1 over here, you have mesh 2 over here and mesh 3 over here. So applying KVL to mesh 1, you get this particular equation. You have V1 minus of 10 into I1 minus I3, because we are in the first loop, hence I am giving more priority to I1, is equal to 0 and we get this V1 equation. Then we are going to apply KVL to mesh 2. So the V2 is equal to, V2 is directly parallel to this 10 ohm resistor and hence V2 is equal to I into R. The R is 10 ohms and the I is I3 current also and I2 current also. Hence you have V2 is equal to 10 into I2 plus I3. Now if you look at this, both the equation that you have got, equation 1, equation 2, you need to find out this Z parameter from it. And the Z parameter equation says we need to have I1, I2 and V1, V2. But if you look at the equations that we have got V1, V2, but I1, I2, I3. But I3 is not required, only I1, I2 is required, where I1, I2 are the incoming currents to port 1 and port 2 respectively. So you need to eliminate this I3 factor from this. Hence what is done is that we are applying KVL to mesh 3 also. When you apply KVL to mesh 3, you will get this particular equation. All the steps are solved over here. If you have any doubts in solving KVL, KCL, how to apply KVL, KCL, a detailed video on KVL, KCL is uploaded on the YouTube channel in network analysis playlist. So you can see the video from there and then come over here. So you'll be able to understand how are these equations written. So once you get the third equation also, if you see, you're getting I3 in terms of I1 and I2. So what you can do is that you can substitute this particular equation in the equation 1 and equation 2. So when you are substituting that, you will get equation 4 and 5. So when you substitute 3 in 1. So when you are substituting the third equation onto the first equation, you get V1 in terms of I1 and I2. When you are substituting the third equation in the second equation over here, you will get V2 in terms of I1 and I2. So you have V1, V2 and I1, I2. I hope I'm very clear with this. Hence finally you will get all these Z parameters. How do you get it? We have the standard equation of Z parameter, which is over here. Just compare this equation with the equations that you have got over here with the fourth and fifth equation and you will get Z parameters. Since it is Z parameter, impedance parameter, the units is going to be in ohms. I hope I'm very clear. The middle steps are clearly solved over here. So you can solve yourself and compare with these steps and see whether you're getting such equations or not. So to just summarize this, what we are doing is we are trying to see the particular equation, and our basic aim in order to solve the z parameter is to get in this particular form. Hence, knowing the equations are very important. So what I do is that I apply KVL to mesh 1, I apply KVL to mesh 2, I apply KVL to mesh 3, and I get these two equations and the third equation also. I try to substitute the third equation onto my first and second equation, and I get the fourth and fifth equation. Why do I do so? Because my first and second equation have this extra parameter I3, and I require the first equation to have V1, I1, I2, and the second equation to have V2, I1, I2 because of the standard Z parameters. So just do the substitution work. All the steps are solved over here. Then get the final equation, compare it with the standard equations, and you will get the value. Similarly for Y parameter, what you have to do is that these are the standard equations: I1, V1, V2, I2, V1, V2. Again, from the given equations you have to do certain substitutions, and as I mentioned over here, and try to get the equation in terms of I1, V1, V2, and I2 in terms of V1 and V2. So once you get these two equations very clearly, you can compare it with the standard equation and solve out the question. So all these steps are given in this particular notes. The notes are present in description box also. You can download it from there and solve it yourself and compare it with this. If you have any issue, you can please let me know. So if you look at this particular network, this network will be given to you. You have to identify where is V1, V2, where is I1, I2. Once these two particular parameters are identified, apply simple KVL in all the meshes, and please try to compare it with the standard equations. That is the Z parameter equation and the Y parameter equation. Once you get those particular equations, you will get the Z and the Y parameters. Now, how do you solve this particular question in GATE exam? So the point is, imagine you get the Z parameter. Now, as we solve the entire Y parameter over here, right, you can solve it very quickly just by saying the Y is Z inverse. If you have seen over here, there are groups, right? Y is inverse of Z. Similarly, G is inverse of H. Similarly, inverse ABCD parameters are basically inverse of ABCD parameter. So what happens is, you have got your Z parameters, you have got your Y parameters, but if you want to solve the Y parameters quickly, once you get the Z parameters, just find out the inverse of this Z parameter. So how do you find out inverse? The formula is given over here. If there is a matrix A, B, C, D, the inverse will be 1 upon AD minus BC. D comes over here, A comes over here, it becomes minus B, it becomes minus C, and try to find out the answer. So I hope I'm very clear with this. So yes, so that is a way you can solve it quickly. Instead of solving the entire Y parameter equation, once you get the Z parameter equation, just do the inverse of it, you get the Y parameter equation. It will be same as you have got above. Now, similarly for other equation like ABCDH, please get the equations that you have got through KVL and KVL in the standard format and try to find out the answer. Now you have in GATE exam, what happens is that in GATE exam or in any kind of competitive exam for that matter, specific parameters will be asked. For example, in GATE exam, specific parameter questions are asked. So try to apply the formula directly and solve. For example, as you found that in this particular question, it was directly the circuit diagram was given to you and all the parameters was asked. But in a competitive exam, mostly what happens is that they mostly ask you one particular parameter, one particular equation. Hence, they have asked you find Z11. Now what is your Z11 equal to? V1 upon I1 for I2 is equal to 0. How do you get this? See the equation of Z parameter. So the Z11 is equal to V1 upon I1 if my I2 is 0. So if I put my I2 is equal to 0, directly my Z11 will be equal to V1 upon I1. Am I correct? I repeat. If I want to find out Z11, I'll just put my I2 as 0. And if I put my I2 as 0, my Z11 is equal to V1 upon I1 when my I2 will be equal to 0. So what I do is, the circuit diagram is given over here. Fine. Z11 will be equal to V1 upon I1 for I2 is equal to 0. So since my I2 is equal to 0, my R3 I can consider as open, right? If my no current can flow through this particular branch, it means that the resistance is very high. That means the resistance is infinite, and an infinite resistance is given by a open circuit. Hence, simply find out KVL over here. We have V1 minus of 1 into I1 minus of 1 into I1. The I2 is equal to 0. Hence, my V1 upon I1 when my I2 is 0 is given as 2 ohms. So I hope I'm very clear with this. How did we find out? So instead of finding the entire, instead of applying KVL here, KVL over here, and then trying to get the standard equations, compare to the standard equations, and then trying to find out Z11, what you can do is just apply the formula Z11 is equal to V1 upon I1 for I2 is equal to 0. Imagine they would have asked you for Z12. Z12 would have been V1 upon I2 for I1 is equal to 0. Imagine they would have asked you for Y22. It would have been I2 upon V2 when my V1 is equal to 0. So just apply that condition in the circuit diagram and apply the KVL and you will get the final Z11 parameter. I hope I am very clear with this. Hence the Z parameter value is equal to 2 ohms. And that is my answer. So I hope I'm very clear with this. So I've tried my best in order to explain you these two-port network parameters. I have not explained in detail all the steps I've done for solving the KVL and KCL because that's the basic part. So you'll find those steps in my notes also. Please download from description box. However, if you have any kind of confusion and doubt, please do let me know. Do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram. The link is given below in the description box. There are a lot of formula sheet, lot of summary type of videos which are uploaded on Instagram on regular basis. So you can follow me on that so that you get updated for all the things happening on Instagram also. My channel is Explore Edu to Teach. Thank you so much guys. God bless you.